Hydronic heating is a heating system that uses water as the medium to carry heat. Hydronic heating utilizes a boiler. A boiler heats water and creates steam to heat a home by pushing it through radiators. There are two basic types of hydronic systems: steam or hot water. A boiler is defined as a closed vessel in which water or other liquid is heated and steam is then formed. The steam generated from the water can drive turbines or engines or supply heat in our case.
Every residential hydronic heating design will require the following basic elements to heat the home. A liquid medium. Traditionally this has been water, but some other liquids like antifreeze mixes are used. A manifold connected to the thermostat. The plumbing manifold is the hub for directing water flow and room temperatures. Tubing, or some other form of plastic tubing, is pretty much universal with all hydronic systems, with very little in the way of copper or other rigid piping is used. Heat exchanger, the radiator baseboard heater, or in floor elements that transfers heat into the home, and a pump to keep the heated water in circulation. There are different piping arrangements. There are single pipe, series pipe, and two pipe systems. A single pipe delivers steam into radiators where the steam is condensed back to water. The radiators and supply pipes are pitched so that gravity eventually takes the condensate back down to the boiler where it is turned into steam again. A series pipe radiators are connected in series like a series circuit. It uses a single pipe that runs through all the radiators. A series system uses the least amount of material and therefore is the cheapest to install. The end of a series loop may require larger radiators or baseboards. Two-pipe direct return. A two-pipe system, there is a second path for a return for the water. It may involve pumps as well as gravity-induced flow. The return pipe takes the most direct pipe back to the boiler after each register. The two-pipe reverse return system, also called the three-pipe system. In this system, the water has to go through all of the registers before it can return to the boiler.
To understand why hydronic heating is so effective, it is important to understand how heat transfer takes place. The transfer of heat occurs in three ways. Conduction. This is the movement of heat through objects that physically touch, where heat moves from the warmer object to the colder object. Standing barefoot on a beach with hot sand or a cold kitchen tile floor are good examples of this process. Liquids are much better conductors than gases. Convection. This occurs when fluids or gases transfer heat while they are being circulated from one area to another. Traditional heating systems that used forced air are perfect examples of this type of heat movement. Just picture the warm air that flows out of the vents in a room to understand this process. Unfortunately, air and other gases, as mentioned above, are poor conductors of heat. Radiation. Thermal radiation is heat that travels in invisible waves through empty space. It is not something that can be blown away by the wind or moved. It is simply absorbed by the person or object that is in the path of the beam of energy, and is a far more effective means of transferring heat. Hydronic heating works so effectively in keeping your family and home warm over conventional forced air systems because it utilizes conduction and radiation in heat transfer along with a superior conductor of heat in the form of liquid. On the other hand, forced air relies solely on convection and air. Air is such a poor conductor of heat that it is often used as a means of insulation, as can be seen by its use between the panes of energy-efficient windows.
Radiators are what transfer the heat of water or steam to the area that you are trying to heat. Steam radiators are the oldest of the radiators. They were around when electric pumps weren't to pump hot water. This is why steam is often used in skyscrapers, because steam rises, making it easier to transport than water. A hot water radiator consists of a sealed, hollow metal container filled with hot water by gravity feed, a pressure pump, or convection. As it gives out heat, the hot water cools and sinks to the bottom of the radiator and is forced out by a pipe at the other end.
There are many benefits of hydronics. These benefits include the ability to have multi-zones, ability to put warm floors and tiles, balanced humidity levels, and little sound. Having multi-zones is the ability to have a custom temperature for the different rooms in the house. Hydronics also give you the ability to heat the floors in your house. Tubes are laid under the floor and hot water is pumped through them. Hydronics allow for balanced humidity levels because a hydronic system has only heated water. It does not blow hot air, which dries out the air. Hydronics is quiet because it does not have the sound of it turning on and off throughout the night.
Hydronics is also cost effective. Very few people can remodel a home on a limitless budget. For this reason, understanding the typical cost of a heating system is important when it comes to weighing the quality and overall expense. The upfront cost of an hydronic heating is more expensive than a bare bones traditional heating system, but the long-term savings from reduced energy consumption can help to make the radiant heat less expensive in the end. Typical installation cost for hydronic radiant floor heating can range from $3 to $7 per square foot. This is a broad range because every region is different in terms of contractor fees, and there are so many different methods of installation. Additionally, multiple installation methods can be used on one project, which further complicates general cost estimates. It is important to note that this does not include the boiler and pump system, which again are highly costly.
Single-story slab on wet grade installation of radiant flooring can help keep costs lower because there are no expensive prefabricated solar panels that need to be purchased. Also, there is only one trip for pouring the concrete, unlike other wet applications, and the thermal mass and insulation are already in place, unlike dry installations. When looking at the real costs of a residential heating system, it is important to factor in lifetime costs with the upfront expenses. A homeowner will typically save somewhere between 20 to 40% with a radiant heating system using hydronics as compared to a traditional forced air system. This means the higher initial cost of hydronic heating can be recovered for homeowners who plan on staying for the long term. Other applications for hydrodynamics include driveway heating, such as in the floor heating, and you can also use hydronics to heat your pool.
So why not go out and buy yourself a nice hydronic heating system and have it installed into your home? After the upfront cost, your home will be running not only more cost efficiently, but more heat efficiently.
Occurs when fluids or gases transfer heat while they are being circulated from one area to another.
Here in about 5 minutes.
Traditional heating systems that use forced air are
Stop for a second. Just start before that happened. Do you know where you were?
convection.
Okay, just say that again.